This is accelerated geometry combining sections 4.4 and 4.5. If we had been in school, the class before this, we would have gone to the computer lab and you would have done a Sketchpad lab to determine what the shortcuts are for showing congruence in triangles. So we may have done that. If we did not go to the lab, then there are two great videos here. One of them, the first one, is talking about the shortcuts that do work, and then the second video talks about why the two of them don't work, SSA and AAA. Okay, so after you have watched those videos, then come back and I have a review of the conjectures that you will have learned from watching those two videos. So this is the first conjecture that talks about triangle congruence. So basically what you're trying to do here is to show that two triangles are congruent to each other. And in order to do that, you would actually have to show all three corresponding angles are equal and all three corresponding sides are equal. So you'd have to show 6 equalities. What the shortcuts do is boil it down to 3. So instead of showing all 6 equalities in the SSS side, 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 all you say is if 3 sides of one triangle are congruent to the 3 corresponding sides of another triangle, then the triangles are congruent. So here I show that if this side is equal to that side, if side BC is equal to side EF, and if side AC is equal to side DEF, then I don't have to worry about the angles being equal. They automatically will be. And I can say that triangle ABC is congruent to triangle DEF. So SSS stands for those 3 sides, side, side, side. The second one is SAS. Now look how this is set up. Side, angle in between, and then a side. So this is a side, there's a side, and they put the A in the middle to show you that A is the included angle between those 2 sides. So conjecture 25, put this on your conjecture list. It says if 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of another triangle, then the triangles are congruent. So I have side AB equaling side DE. So that's a side that matches up. So side 1, let's call it. Okay, side BC matches up with side EF. And this angle B matches up with this angle A. So see how we have side, angle, side. 2 sides and the angle in between them. If those are all equal, then you can say triangle ABC is congruent to triangle DEF. This one says I have 2 angles and the side that is between them. So if 2 angles and the included side of one triangle are congruent to 2 angles and the included side of another triangle, then the triangles are congruent. So this is an angle 1 equal to this angle 1 over here. This is a side equaling this side. And this angle is equal to this angle. So what do I have? An angle and an angle with the side in between them. So an angle, and the side in between them. So ASA. When that happens, you can say that the 2 triangles are congruent to each other. This is the 4th and final one. This is 2 angles and a side not between them. You can also write it as AAS. So this has 2 angles. Here's an angle 1. Here's an angle 2. Okay. Here is angle 1. And here is angle 2. So angle 1 equals angle 1. Angle 2 equals angle 2. And there is a side that is not between them over here. So here are my 2 angles. Not the side between them, but a side that is not between them. So two angles and the side not between them. So if two angles and a non-included side of one triangle are congruent to the corresponding two angles and non-included side of another triangle, then the triangles are congruent. So you can say that triangle ABC is congruent to triangle PQR. Now these are the two that do not work. AAA does not work because look how these angles, this one is equal to that one, this with the 2 marks is equal to this with the 2 marks, and this with the 3 marks is equal to this with the 3 marks. So the angles, the corresponding angles are equal, but you can definitely see that the two triangles are not congruent. So AAA does not work. SSA does not work, and I always say that doesn't work because look what happens. That's the same thing as ASS, and we can't say that in geometry class. In fact, I'm going to get my eraser and erase that so that we don't even see that, because that's not good to write such things in geometry class. So now, why does SSA not work? Here's a side equaling this side equals this one, and this angle equals this one. So it's an angle here, and two sides, the angle's not between them, so it'll be ASS or SSA. So I can get two congruent looking triangles, but look at the second case. I can take this side and keep it the same length and just move it over here with the same length, and look what happens. When I move it over there, this becomes my new triangle. So the original triangle here does not look like this triangle here. So SSA will give you two triangles, not just one congruent triangle. So SSA does not work either. And the video also gives you an explanation of that. Now, the reason that we learn these congruent triangles is that we can do proofs. These are what I call two-column proofs, and I'm going to show you how I would like them done. So they are giving you some information, and you have to show something. So they are showing you that this is what they want me to prove, that triangle AMD, this lower triangle, is congruent to triangle BMC, the upper triangle. Okay, they give me some clues along the way. So when I get the clues, I usually mark them. So angle A is equal to angle B, and they give me that AM is equal to MB. So I have those marked. Okay, now if I'm trying to figure out that those two triangles are congruent to each other, I either need SSS, SAS, ASA, or AAS. So what do I have so far? I have an angle here and an angle here. I have a side here and a side here. Now, I know from the past that this angle and this angle are vertical angles and they are equal. So in one triangle, look what I have. An angle, and a side between them. So I think an angle and a side between them is how I'm going to prove that these two triangles are congruent to each other. So that's my thinking. Now I'm going to actually write it out formally. So you say angle A equals angle B because it's given to you. Each statement that you make has to have a reason, and that reason is either given or a geometric fact that you know. Okay, they tell me that AM is equal to MB, so that is also given. And then I thought about angles 1 and 2, and I said I know that they are equal because vertical angles are equal. So you don't just say because they're vertical angles, you say the whole thing, vertical angles are equal. So now I have shown the three parts that I need for the angle, the side, and the angle. So this gave me an angle, this gave me the side, and this gave me the angle, and the side is in between the two angles. So therefore, triangle AMD is congruent to triangle BMC, and the reason is ASA. So all these other reasons you need to write out, these shortcuts you can abbreviate. And here's one more example. Example B says, I am given that AT is an angle bisector. So this is an angle bisector. Okay, an angle bisector tells me that it bisects an angle. So this angle and this angle are going to be equal to each other because that's an angle bisector. So this is just my thinking. LA equals SA. So I have a side, I have an angle, and I need either another angle or side. And look what I see. This TA is a side in both triangles. So I think I'm going to have SAS. So after I've thought about it, to show that those two triangles, LAT and SAT, are congruent to each other, I think I'm going to be able to do it by SAS, but now I have to formally write it down. Okay, first step, AT is an angle bisector. That's given. So you have to write the givens. Now, what does that tell me? Because it's an angle bisector, that doesn't give me an angle or a side, but it tells me some information. It tells me that angle LAT is equal to angle SAT. And the reason for that is, by the definition of an angle bisector divides an angle into two equal angles. Okay, then I go to my next given, LA equals SA, so that is given to me. It doesn't tell me anything extra at this point because I'm going to use the next fact, that TA is equal to TA because they are the same shared segment. So now I have two pairs of sides that are equal and an angle that is a pair that is equal in both triangles, and the angles between the two sides. So therefore, the two triangles are congruent by SAS. Now, to complicate matters a little bit, because I have a couple minutes left before my video runs out, I'm going to go back and I'm going to say, I could have done this a little bit differently if I wanted to. And that is, I still have LA and SA being equal to each other, so I would still have that. That also could tell me that I have an isosceles triangle. And in an isosceles triangle, base angles are equal. So instead of using this, I could have said angle L is congruent to angle S, because if two sides of a triangle are equal, then base angles are also equal. And then I still would have had to have used this part here, that this is an angle bisector, and that those two angles here would be equal. But this would now be different, because I would have an angle, a side, and an angle. So this would then be by ASA. So sometimes there's more than one way to prove one of these problems that they give you. So hopefully this will give you a head start, a little idea of what you're going to be asked to do in the homework for today.